Okay, we're gonna remember how to reduce radicals because that's gonna show up in the square root, the quadratic formulas in a minute. There's two different ways to do it. There's to find the perfect squares, which is what I kind of taught the honors kids, and then there's making a factor tree, which is really my favorite way, which I did not teach the honors kids, but sometimes I like it better. So finding perfect squares, if I had the square root of 20, I'm thinking, what number do I know the square root of that gives me 20? And so you should think 4 and 5, because 4 times 5 is 20, and I know the square root of 4, so the square root of 4 is 2, and then I have a square root of 5 left over, and that's it. The problem is when you get to big numbers like 320, can you do that in your head? Because the best number that multiplies, like, do you know what multiplies give you 320 at the top of your head? I don't. So I would, the correct answer is 64 and 5. Well, I don't know what 64 times 5 is off the top of my head, so I would never choose to do it that way, but it works. And so the square root of 64 is 8 square root 5. So this way is easy for doing it this way. This way is a little bit tougher. So there's an alternate way. You can make a factor tree. And so what you do is you say, what numbers do I know to multiply to give me 20? Well, let's say we pick 2 and 10. 2 times 10 is 20. And then so that I break down. 10 can break down because I need to get the prime numbers. 10 is 2 times 5. So now all of these are prime numbers. So I really have 2 times 2 times 5. 2 times 2 times 5. And so then I need to say, find groups. So what do you have the same of? Well, I have 2 2s. So if I have 2 2s, I get 1 that comes out. 5 has no friends, so he stays in. Honors, or in algebra 2, we talk about you have to have 2 friends to come outside. If you have no friends, you have to stay inside the square root bucket, square root sign. So 320 might work a little bit easier. Now, see, that looks like a lot of work here as opposed to this, but not everybody thinks in perfect squares. So in this guy, I'm going to break this down. I'm going to pick 32 and 10 because it multiplies to give me 320. So then 32, I'm going to pick what, 4 and 8? 4 times 8 is 32. And for 10, I'm going to break down into 2 times 5. Well, these two guys are done. They're prime numbers. These two guys are not. They are not prime numbers. So 4 is 2 times 2, and 8 is 2 times 4. And then I still have this 4 that breaks down into 2 times 2. So now, the tricky part of this is sometimes kids get lost. Because I put all of these other numbers. You come to the bottom of the little tree. You've got a 2, a 2, a 2. This guy kept going down, 2, 2, and 5. So I have 1, 2, 3, 4, 5, 6. I have 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6, and I have a 5. And so the rule is for every 2, 1 comes out. So here's 2 2s, here's 2 2s, and here's 2 2s. So that means I have a 2 times 2 times 2. 5 has no friends. He stays inside the square root. 2 times 2 times 2 gives me 8 square root 5. It does not matter which way you choose. You get the same answer either way. I will tell you that the red way is Mrs. Chin's favorite way to do it. You pick whichever way your brain works because everybody's brain works